Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper for exam for October-November 2022 variant 1. So let's get started. Question 1 says two blocks A and B are joined by a thin thread that passes over a frictionless pulley. Block A is at rest on a rough horizontal surface and block B is held at rest just below the pulley. Figure 1.1 shows the thread hanging loose. Block B is released and it folds vertically. The thread remains loose until block B has fallen a distance of 0.45 meters. So if the thread is loose, that means that the block was falling under gravity. The mass of block B is 0.50 kilograms. Calculate the change in gravitational potential energy of block B as it falls through 0.45 meters. So we can say that GPE is equal to mgh, or the change in gravitational potential energy equals mg times the change in h. So we multiply 0.50 by 9.8 by the difference in height, which is 0.45. That gives us an answer of 2.205 joules, which we can approximate to 2.2 joules. Part B says the mass of block A is 2.0 kilograms. When the thread tightens, it pulls on block A, which moves to the right at a speed of 0.60 meters per second. Calculate the impulse exerted on the block A as it accelerates from rest to 0.60 meters per second. The impulse is equal to the change in momentum, which we can calculate as mass multiplied by the change in velocity. So the mass is 2.0 and the final velocity 0.60 minus the initial 0. That gives an answer of 1.2 kilogram meter per second or Newton second. Part I says both blocks now move at constant speed of 0.60 meters per second until block B hits the ground and the thread becomes loose. Explain the energy change that takes place in block A after block B stops moving. So now there is no forward force pushing it forward and there is still friction backwards. So it decelerates until it stops. So kinetic energy decreases as it slows down and energy is converted to heat or thermal or internal energy due to the frictional force. Question 2 says a force is a vector quantity. State two features of a vector quantity. It has magnitude, like all physical quantities, and it also has a direction, which is not for all quantities, only for vectors. State the names of two other quantities that are vectors. We have many quantities. We have forces, we have moments, momentum, displacement, or acceleration, but only mention two of those. Part B says a student suspends a spring from a clamp stand and measures the length L0 of the spring. Figure 2.1 shows the apparatus. The student then suspends loads of different weights from the spring and measures the length of the spring for each load. He then plots a graph of the length of the spring against the weight. Figure 2.2 is the graph that the student plots. So this is a graph, length on y-axis and weight on x-axis. And the length on the y-axis at zero load, that means that this is the original length. Now part I says using figure 2.2 determine the initial length of the spring. So at this point we have that is 0.1 and we add 0.02 for each square. So it is 0.12 meters or 0.12 meters. Part I says state what is meant by the limit of proportionality and using figure 2.2 determine the weight of the load that causes this spring just to reach the limit of proportionality. First, it is the point after which the spring no longer obeys Hooke's law, or we can say it is a point after which the force and extension are no longer proportional. And going back to the graph, proportional means a straight line, so it is a point after the straight line. The line stops being straight from this point here, going downwards to see the load that is approximately 10.4 newtons. So we write it down here. The weight is 10.4 newtons. Part I says using figure 2.2 determine the spring constant of the spring. The spring constant is equal to the force divided by the extension. So we will pick one force and see the length of the spring and subtract the original length. So for example, for this point, we have the load in between 8 and 10. So this is 9 newtons. And we go to see the length here. This is exactly 0.50 meters. And the original length was 0.12 meters. So we write down the equation. We have 9.0 newtons divided by the difference between 0.50 and 0.12. This gives an answer of 23.684. We can approximate that to two significant figures according to the numbers here. It will be 24 newtons per meter. Question 3 says a rock climber of total mass 62 kilograms holds herself into horizontal equilibrium against a vertical cliff. She pulls on a rope that is fixed at the top of the cliff and presses her feet against the cliff. Figure 3.1 shows her position. We have some distances here and an angle. Calculate the total weight of the climber. Weight is equal to mass multiplied by the gravity acceleration. So the mass was 62 kilograms and then we multiply by 9.8. That gives an answer of 607.6, which we can approximate to 608 newtons or 610 newtons. Part B says state two conditions needed for equilibrium. The first condition is no resultant force. The second is no resultant moment or torque. So these are the two conditions. Part C says the climber's center of mass is 0.90 meters from the cliff. Calculate the moment about her feet due to her weight. So the moment is equal to force multiplied by the perpendicular distance from the pivot. So the force is equal to the weight, which is equal to 607.8 multiplied by the perpendicular distance 0.90. That gives an answer of 546.84, which we can approximate to 547 or 550 Newton meters. Part I says the line of the rope meets the horizontal line through her center of mass at a distance of 1.2 meters from the cliff, as shown in figure 3.1. The rope is at an angle of 60 degrees to the horizontal. Determine the tension in the rope. Going back to the diagram, here we have the weight of the climber, and this causes the clockwise moment about this point here at the pivot. And the tension in the rope causes an anti-clockwise moment about the same point, but we do not know the perpendicular distance. This is the perpendicular distance, 90 degrees on the force and connected to the pivot. So this distance here can be found by using trigonometry. So if we have a distance like this and we have a line 90 degrees and this distance is 1.2 and this angle is 60 degrees. We have the required distance opposite to the angle, and we have the hypotenuse of the triangle or the right angle triangle. So we can say that sine 60 is equal to the opposite d over the hypotenuse 1.2. So writing that down here, sine 60 is equal to d over 1.2. So the perpendicular distance will be 1.2 times sine 60. And then we can use clockwise moments equal to anti-clockwise moments as the principle of moments here. Since it is in equilibrium, we say that the moments are balanced. So the moment from the previous question, 546.84, is equal to the new moment, which is the tension multiplied by the perpendicular distance, which is 1.2 times sine 60. And then we want to find the tension, so we divide the left-hand side by this here, and we get an answer for the tension 526.197 approximately. We can approximate that to 2 or 3 significant figures, maximum 3 here, 526 newtons. Question 4 says a quantity of gas is trapped by a piston in a cylinder with thin metal walls. The piston is free to move without friction within the cylinder. Figure 4.1 shows the cylinder and the piston. The cylinder is placed inside the freezer. Now part A says the air in the freezer is at atmospheric pressure, which is 1.0 times 10 to the power of 5 Pascal. The area of the piston in contact with the air in the freezer is 2.4 times 10 to the power negative 3 meters squared. Calculate the force exerted on the piston by the air in the freezer. We have pressure and area and we need force. We can say that the force is equal to pressure multiplied by the area, since pressure is equal to force divided by area. And now we calculate 1.0 times 10 to the power of 5 times 2.4 times 10 to the power of negative 3. That gives an answer of 214 newtons. Part I says when the cylinder is first placed into the freezer, the temperature of the gas in the cylinder decreases and the air pushes the piston into the cylinder. Calculate the work done on the piston by the air in the freezer as the air pushes the piston a distance of 0.021 meters into the cylinder. So work is equal to force multiplied by the parallel distance. We have the force 240 and the distance 0.021 meter. That gives an answer of 5.04 joules. Part B says the initial temperature of the cylinder and the gas is 21 degrees Celsius, and in the freezer the temperature of the cylinder decreases to negative 18 degrees Celsius. The thermal capacity of the cylinder is 89 joules per degree Celsius. Calculate the change in internal energy of the cylinder. So we can use Q is equal to C delta theta, the thermal capacity by the change in temperature. The thermal capacity is 89 and the change in temperature is the difference between 21 and negative 18, so minus negative 18, it's like plus 18. That gives an answer of 3,471, which we can approximate to 3,470 joules. Part C says when the temperature reaches negative 18 degrees Celsius, the pressure of the gas in the cylinder is still equal to that of the atmosphere. Explain in terms of the particles of the gas how the pressure remains equal to its original value. We can say that as temperature decreases, molecules lose kinetic energy and collide less frequently with the walls of the cylinder, decreasing the pressure, but as volume decreases, pressure increases again. The decrease in the volume of the metal is much less than the decrease in the volume of the gas. Explain in terms of the particles of the metal why the decrease in volume of the metal is less than that of the gas. We say that molecules in gases have much wider spacing and much weaker forces, so they are more free to move closer. So they have some distance to close between each other. Question 5 says figure 5.1 shows a heater in a bathroom. The heater is placed at the top here. The heater is at a very high temperature and it glows red. The manufacturer states the heater emits light and radiation and it transfers thermal energy by radiation. State the part of the electromagnetic spectrum that transfers thermal energy. That would be infrared radiation. Part B says state one way in which visible light and the radiation identified in A are similar. We can say both are transverse, or we can say they travel with the same speed in air and vacuum, or they are both electromagnetic. Double I says one way in which visible light differs from radiation identified in A. Double I says one way in which visible light differs from radiation identified in A. We can say that infrared has longer wavelength, or visible light has shorter wavelength, or we can say that infrared has smaller frequency than visible light, or vice versa. Part C says some surfaces are better at emitting radiation than others. I says describe an experiment to show whether a black surface or a white surface is the better emitter of radiation. You may draw a diagram. We can say that we have two identical containers like these, two cylinders, for example, and we add thermometers inside each container with hot water inside, and we must label these containers. We can say that these are identical containers, one with black surface and one with surface, and these here are the thermometers to measure the temperature. Now for writing about the experiment, we can say fill both containers with same amount of hot water at same initial temperature to make sure we have a fair comparison, and leave for same amount of time to measure the final temperatures of each container. And then we say the one with the lower temperature is the better emitter because it loses heat more quickly. Part double I says to ensure that the conclusion reached in the experiment in CI is correct, several details of the experiment must be identical when testing the two different surfaces. State two quantities in the experiment that you described that must be identical during the test. We already mentioned some of these above. We can say initial temperature of the hot liquid or hot water. We can also mention room temperature, time of cooling, and amount of water. These are said to be controlled variables. Question 6 says the red light produced by a laser is monochromatic. State what is meant by monochromatic. It is light of a single frequency or single wavelength. Part B says a red light from the laser hits the curved surface of a semicircular transparent plastic block at point B and passes into the plastic. The red light travels through the plastic and hits the straight edge of the block at its midpoint M. Figure 6.1 shows that some of the light is reflected and some of the light travels in the air along the straight edge of the plastic block. The speed of light in air is 3 times 10 to the power of 8 meters per second. Explain why the red light does not change direction as it enters the plastic block at P. That would be because the angle of incidence is 0 or the light is incident at 90 degrees to the surface. So we say the light is incident on the normal or with angle of incidence 0 or perpendicular to the surface. So it only changes speed and wavelength and does not change direction. Part I says at M the angle between the red light in the plastic and the normal is 37 degrees. Calculate the speed of the red light in the plastic. Now for this diagram, the ray exiting parallel to the surface means that the angle of incidence is equal to the critical angle. So the critical angle is 37 degrees. And we have the speed of light in air 3 times 10 to the power of 8 meters per second. We can use the equations for refractive index. Refractive index is equal to 1 over sine the critical angle, and it's also equal to the speed in air divided by the speed in the medium. So we can say, using this part of the equation, that 1 over sine the angle 37 is equal to the speed in air 3 times 10 to the power of 8 divided by the unknown velocity v. So we multiply 3 times 10 to the power of 8 by sine 37. That gives an answer of 1.805 times 10 to the power of 8, which we can approximate to 1.8 times 10 to the power of 8, and the unit here is meters per second. Part I says in the plastic, blue light travels slightly slower than red light, and so the critical angle for blue light is smaller than the critical angle for red light. The laser that emits red light is replaced by one that emits blue light. Now blue light enters the block at P and hits the straight edge at M. Explain what happens to the blue light after it hits the straight edge at M. Now if the critical angle is smaller, this means that now the angle of incidence is greater than the critical angle, which causes total internal reflection. So this is what we will write. The angle of incidence is greater than the critical angle, so total internal reflection occurs with angle of reflection equal to angle of incidence. So the 3 marks here are the angle of incidence is greater than the critical, and the second mark is total internal reflection. The third mark is for the angle of reflection is equal to incidence. Question 7 says the electric starter motor in a car is switched on and off using a relay. The relay consists of a plastic case and 2 flexible spring strips, X and Y, which are made of soft iron. These iron strips act as the switch when a circuit is connected between the terminals W and Z. Figure 7.1 shows X and Y and the plastic case. Figure 7.2 shows the equipment from figure 7.1 inside a magnetizing coil. The magnetizing coil is in series with the 12-volt car battery and switch S, which is open. Switch S is now closed. Explain what happens to the springy iron strips X and Y. So the circuit works and the coil gets magnetized, and the iron is a magnetic material, so it also gets magnetized. So we have opposite poles in the strips, so they attract each other and the circuit is closed. So we say here the current in the coil creates a magnetic field which magnetizes the strips, and they attract each other because they have opposite poles. So opposite poles attract. Part B says the power of the starter motor is 1.8 kilowatts and it is also operated by the car battery. Part I says calculate the current in the starter motor when it is used. We can use the equation P equals VI, or voltage times current, and then we divide the power by the voltage to get the current. We have the power 1800 for kilowatt. We multiply it by 1000 and then divide by the voltage 12 volts, which is mentioned above in the question. That gives a current of 150 amperes. Part I says the starter motor circuit is connected between terminals W and Z. Explain why copper wires with a large cross-sectional area are used for this circuit. We say that copper is a good conductor, and increasing the area decreases the resistance. These features are required for a large current. 150 amperes, that's a very large current. Part C says figure 7.3 shows the relay and the symbols for the car battery and the starter motor. The springy iron strips X and Y act as the switch for the starter motor circuit. Complete the circuit diagram for the motor circuit. So the motor must be connected to the battery from one side. So we connect a branch here for the motor, and the other side must be controlled by the switch. So we connect this part to the switch and the other side of the switch to the battery. Now the current can flow through this side of the motor and then goes to the switch, and when these connect, the current can flow back to the battery, or in the opposite direction for conventional current. Question 8 says the unit of the two electrical quantities, electromotive force and potential difference, is the volt. State one other similarity between EMF and potential difference. We can say the definition that both are energy needed to move a unit charge or 1 coulomb of charge. State one difference between EMF and potential difference. We can say that potential difference is across 2 points in a circuit, but EMF is across the whole circuit, not a part of the circuit. Question C says a battery consists of 4 cells, each of EMF 1.2 volts in series. Part I says calculate the EMF of the battery. We multiply the voltage of one of the cells by the number of the cells, so 4 times 1.2, that gives a total of 4.8 volts. Part I says the battery is connected in a circuit with 4 12 ohm resistors. Figure 8.1 is a circuit diagram. Calculate the total resistance of this arrangement. So we have a branch here and a branch here, which means this section is in parallel with this section, but outside we have a series connection. Let's start from the inside. We have two 12 ohm resistors in series, that's 24 ohms, in parallel with a 12 ohm resistor. So we calculate the parallel connection, 24 times 12 over 24 plus 12. That is a total of this section of the circuit. And then we add the series connection here. So we add 12 ohms. That gives a total of 20 ohms for the whole circuit. So this section has a total resistance of 8 ohms and this has 12 ohms, and the voltmeter is connected with the 12 ohm resistor. Part I says calculate the reading on the voltmeter in figure 8.1. So the total voltage was 4.8 volts. That was given to the total resistance of 20 ohms. And in series, we can say that the voltage is proportional to the resistance, so we can perform cross multiplication on this. So what voltage goes to the 12 ohm resistor only? We multiply 4.8 by 12 and then we divide by 20. We get a total voltage of 2.88 volts or 2.9 volts across the 12 ohm resistor. Question 9 says only one isotope of gold occurs naturally on Earth. State what this indicates about the nuclear structure of all the naturally occurring atoms of gold on Earth. So if there is only one isotope, they have same number of protons and neutrons. There is no variation. Part B says there are several artificially produced isotopes of gold. Gold 198 is an artificial isotope which is used in medicine and in scientific research. Gold 198 decays by beta emission to a stable isotope of mercury. Determine the number of protons and the number of neutrons in a nucleus of this isotope of mercury. So if we have the gold nucleus 198 and 79 emitting a beta particle which is 0 and -1, we have the final nuclide of mercury with the number 198 as a nuclear number, because 198 plus 0 gives 198, and the proton number actually increases by 1 to 80, so that 80 minus 1 gives 79, so the number of protons is 80, and the number of neutrons, that's 198 minus 80, so it is actually 118. Part I says a sample of gold 198 is placed near to a radiation detector in a research laboratory. The count rate is recorded at the same time every day for 32 days. So we have the starting point here is at 390 and the activity decreases with time. Using figure 9.1, determine the background count rate. That is the count rate at which the radiation stops decreasing or the activity stops decreasing. So it is at this point, which is approximately 20 counts per minute. That was the unit for the y-axis. Now, III says, using figure 9.1, determine the half-life of gold 198. We started with 390. We must first remove the background from this count rate, so minus 20. That gives an answer of 370. And then to get the half-life, we subtract, and then to get the half-life, we divide that by 2. That gives an answer of 185. Then we move back to the graph to get the time from the x-axis, but the graph contained background radiation, so we must add background radiation to 185. That gives an answer of 205. So we go with this value, 205, to the graph. This is 210, so 205 is in between. That is approximately at this point here. So we say if this is 2, this is approximately 2.8 days. 2.4, then 2.8. So we write down the answer 2.8 days. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing, and I will see you in another video.